GameSci.com. GameSci.com.
Hello, welcome to Selection or Control Statements. A selection statement is so named because it selects which code to execute. In some books, they call them control statements because they control the path the program takes. Let's start with the simplest and easiest of the selection control statements, the if statement. If something is true, I'm going to execute some code. And when it's false, I will skip that code. The best way to explain it is to illustrate it. So let's trace this programming code example. We're going to set up a variable score here, and you can see that score has the value 2 currently in it. So I'm going to do if score less than 3. Well, that's 2 less than 3, and 2 less than 3 is a true statement. When this statement is true, what's going to happen is we will select this code to execute and print out it is true. And you can see it is true came out on the output. It's as simple as that. When the condition is true, we execute the code between these curly braces. When it's done, it will fall through and continue on with the computer program. Now let's run this again, but this time let's set the score to 4 before we start. You can see I've updated the value score in the variable. It is now 4. Now when we run the if statement, it's 4 less than 3, which is a false statement. When this statement is false, what's going to happen? We are going to skip past this code and continue on with the program. It's called a one-way decision. When it's true, we will execute that block of code. When it's false, we will simply skip it. Fairly simple. Let's go again with score equal to 0 this time. So I'm going to update the variable score to 0. And when I run the code now, score, you can see has the value 0 in the variable. When I extract it and do score less than 3, 0 less than 3 will evaluate to true. And when it's true, what happens? We go inside the code and execute system.out.println it is true. And you can see once again, it is true is shown up on the output for a second time. Again, it's called a one-way decision. I'm going to execute that one block of code when the condition is true, or I'm going to skip it. Either way, I'm going to continue on with the program after the if statement. Any code that appears after the if statement will execute. It's that simple, folks. Let's go on to a upgraded version of this called the if-else statement. Again, the if-else statement is a selection or control statement. Some books, some computer science textbooks call these selection statements because it selects which code to execute. Other books call them control statements because they control the path the program takes. Either way, selection or control statement, the if-else statement is a two-way decision. You have two different options for the code to execute, and the best way to see it is by tracing the code. So let's start with 9 in the damage variable over here and 10 in the health variable, and let's see how this code works. 9 greater than 5 is a true statement. 9 greater than 5 is true. As you might suspect, we're going to go inside and execute the code in the if statement. Health equals health minus 3, and what happened here is we subtracted 3 from the health variable and it went down to 7. Do you see why it's called a selection statement? We selected this code to execute. What happens when we're done with the code in the if portion? When we're done with the code in the if portion, we skip past the else. This is a two-way decision. You will select one path and skip the other. So we skip past the else and continue on with the program. Let's start again, and this time let's set the damage variable equal to 2. What happens when damage is set to 2? Here's 2 in the damage variable at this point. We have 7 still in the health variable. Let's see what path this program chooses to take. 2 greater than 5 is a false statement. As a false statement, what's going to happen is we will not execute the if portion, but we'll go to the alternative else portion. So you can see by the line, because damage greater than 5 was false, we're going to go down and execute the else code. When we execute the else code, the health equals health plus 1 will go, and our 7 became an 8. This is called a two-way decision, and you can see it's taking the second path, the else portion, because the condition was false. The Boolean value up here evaluated to false, 2 greater than 5 was false, so it selected the else code to execute. And of course, it continues on and finishes up the if-else station. If there was any code below this, it would execute. Let's try it again. Set damage equal to 13 this time, and trace the code when a larger number is in the damage variable. So damage is set to 13. Our health still retains its previous value of 8. 13 greater than 5 is very much a true statement. As a true statement, it does what we would expect. It executes the if portion. When the condition or Boolean is true, we will select this piece of code to execute. Health equals health minus 3 will execute, and you can see the updated 5 in the health variable. When it's done with the if portion of the if-else statement, it will skip past the else and continue on with the program. One more time, and we'll wrap it up. Start again with damage variable set to 5, and let's trace what this code does. You can see the updated value of 5 in the damage variable. You can see the health variable now contains a 5 in it. 5 greater than 5 is a false statement. 5 is not larger than 5. So this comes out to be a false statement. What do you expect to happen when that statement is false? We expect it to skip the if and go to the else and execute the code in the else. When it executes the code in the else, it'll go inside this block. Everything between these two curly braces will execute when the condition is false. Health equals health plus 1. We've bumped the health variable back up to 6. So there you have it. There's two full examples of tracing the if-else statement through both paths the program could take. Do you see why it's called a two-way decision? It will select between one of two paths to execute. And that selection is based on this condition or Boolean value being true and false. When it is true, I will select this code to execute. When it is false, I will select this code to execute. Fairly simple and straightforward. That is the if-else statement. It's an upgrade to the if. Moving on, let's take a closer look at what produces the true-false answers. What produces a true-false answers is something we call relational operators. Now, some of these operators you probably learned in the 3rd grade. Things like the less than operator and the less than or equal to than operator, the greater than or equal to operator, and the greater than operator. Some of these might be new. The equal operator says if both sides are the same, return true. The not equal operator, if the two operands are different, return true. We'll see how they work by tracing the code. But one thing I can tell you about all relational operators is they all return true or false. When they return true false, they are excellent for use in an if-else statement. I'm also going to show something new here. When there is one and only one executable statement in an if-else statement, the curly braces aren't required. Now, I myself prefer to always put in the curly braces, but if there is one and only one executable statement in the if-else, I am not required to use curly braces. Also, if there's one and only one statement in the else portion, I'm not required to use curly braces. So just to show you an example where you don't have to put in the curly braces, we'll run this without the curly braces. So let's go through this first. We'll set up 19 in the age variable, and we'll look first at the less than operator. So with 19 in the age variable, 19 less than 18 is a false statement. Always has been, always will be. 19 is not less than 18. Because that condition is false, what is the code going to do? Why, it's going to go straight to the else. It's going to go straight to the else to execute the else portion, and you can see it prints the word false onto the output, and a false showed up on our output. Pretty simple. Now let's illustrate the less than or equal operator. Once again, let's put an 18 in the age variable, and we'll look at 18 less than or equal to 18. 18 less than or equal to 18 is very much a true statement. Since they are equivalent, the equal portion will make that relational operator true. All relational operators return true or false, and in this situation, this operator is going to return true. As a true statement, you know what it's going to do. It's going to execute the if portion of the if-else statement. It's going to print line the word true, and true shows up here on our output. All of these are fairly simple. I'm just running through the examples to show you how all of them work. Let's do the greater than operator now. Let's replace the value age. Now, one of the reasons I'm showing you different values in the variables is I want you to understand that every time this code executes, it could take a different path. It all depends on what the value in age is and what the relational operator is. I need you to understand that this is what makes it computer programmable. It makes it programmable because every time this software runs, it could select or choose a different piece of code to execute. With 16 in the age variable and looking at the greater than operator, 16 greater than 18 is a false. So during this particular execution of the code, since the condition is false, it will choose to execute the else portion of the code, and we'll output the word false, and you'll see false show up here. Let's look at the greater than or equal to operator. We'll put 20 in the age variable, so at the time this code executes, we're looking at 20 greater than or equal to 18. 20 greater than or equal to 18 is very much a true statement. As a true statement, we'll select the true path. We'll output the word true, as you see it show up on the output down here. And of course, when it's done executing the if portion of the code, it will skip past the else. Look at that line right here. It never, I repeat, never executes both. It will select the if and skip the else, or it will select the else and skip the if. Let's look at the equal to operator. That's two equal signs right next to each other, and see how the code behaves with that relational operator. Here we set 17 in the variable age. And again, I'm changing these variable values to show you the dynamic nature of this code. Every time it executes, it can choose a different path based on the value of the age variable. So 17 equal to 18 is clearly false. As a false value in the true false Boolean operator, equal equal, as a false value, it's going to select the else path. The else path says execute the print line of false, and a false shows up on the output. Let's look at the not equal operator now. This is the last relational operator we'll be looking at. I hope you like this slide. Now, the code doesn't dynamically change its relational operator. I'm going through all the different 6 relational operators to show you how they behave and how they affect the if-else statement. Age now has the value 21 in it. So at the point this code executes, 21 not equal to 18 is very much a true statement. Left operand is not equal to the right operand, so it returns a true. As a true statement, as you would expect, it comes in and executes the if portion of the code, and a true shows up on the output. And of course, when it's done with the if portion of the code, it exits the if else. Remember, it will only select one piece of code to execute. If it does the if portion, it will skip the else. That's my slide. That's all 6 relational operators. Keep in mind, relational operators return true-false values, and those true-false values could be used in if and if-else statements to determine which code executes. That's the whole point of it, deciding which code executes. That's what makes a computer a programmable machine. Every time the software runs, it can decide to execute a different section of code. Let's move on to the next slide. I want to introduce something called a flowchart. A flowchart is a graphical representation of the logic of a computer program. Not everybody knows how to read code, so what flowcharts do is they provide a way for non-technical people to see what the code is doing. Flowcharts also provide a way for designing code, for determining how you want your code to execute. Whenever you type in a piece of code, there's 2 problems to solve. You have to solve the logic of the program. What is the sequence of commands I want to execute? And you have to solve the syntax of the problems. Am I getting all my curly braces, semicolons, and double quotes in the right spot? Well, by breaking that problem into 2 pieces, designing the code first to solve the logic of the problem, when you have a good design, you can then type in the code and only worry about the syntax. Let's see what a flowchart is and what a flowchart does by once again tracing some code. What I have over here is what I call generic or pseudocode. This is not executable code. This is not something you could type into an IDE and have it run. It's a generic piece of code or pseudocode that illustrates the example of an if statement. I'm going to draw lines here to show you how the if statement corresponds to the generic flowchart for the if statement. We already know if some true-false condition is going to occur, we're going to decide to execute this code or not execute the code. True-false statements in flowcharts always appear in diamonds because diamonds have these nice points on the edge we can label true or false. Anything that evaluates true-false, like a relational operator, always appears in a diamond in a flowchart. And that's what this arrow is showing you. This true-false condition is represented by that diamond in the flowchart. Now let's say that condition was true. If this condition was true, we're going to go inside and execute the statements. And that's what this red line is showing you. The condition was true, so I will take this path and execute the block of statements in the if code. When it's done, I will leave the if portion of the code and continue on with the program, and that's what this arrow is showing you here. After the block of statements executes one time, I will leave the if statement. Now let's run through this again and let's show the false path this time. What happens when this condition is false? I execute this code again, and this time our boolean or our condition is false. What happens when it's false? Well, first of all, we're in this diamond evaluating the true-false statement, and this time it comes out false. Well, we know when it's false in the code, we just skip the if block. We execute nothing. Over here on the flowchart, you can see it will take the false path out of the diamond, go this way, and skip the statement. What we're doing is we're graphically showing you that it's skipping that block of code, and that's exactly how we expect the program to behave. When the condition is false, skip the if portion of the code and continue on. There you have it. That's called the flowchart for the if statement. There's also a flowchart that represents the if-else statement. It's formatted slightly differently, but it's not a whole lot different. Recall that the if-else statement provides a two-way decision. It selects one of 2 paths to execute and will only execute one of those paths. Let's trace the code again with arrows on the flowchart to show you what's doing. Here we have our true-false statement. We're going to assume this time it's true. True-false statements are always evaluated inside of diamonds inside a flowchart. So I'm going to evaluate this true-false statement and select the true path. When this if statement is true, I will execute the first block of code, the block of code within this set of curly braces right there. That code says take this path out of my diamond and execute statement block number 1. When it's done executing statement block in the if portion of the statement, it's going to skip the else portion and continue on with the program. And that's what this arrow is showing you. I'm skipping the else portion. I will not execute the else code, and I'll continue on with my program after the if-else statement. This path should be familiar to you now. If the statement is true, I will execute the first block of statements and skip the else. Now let's run through it on the false path. Again, we'll execute the if true false statement in the parentheses. This time we'll assume the result will be false. So we're here in the diamond evaluating the true false statement. What happens when the statement is false? We select a different path. That's why it's called a selection statement. It's a selecting different code. If the condition is false, we will go to the else portion of the code, and that's what this arrow is showing you. Go select the else code to run. That's what this line is showing you. Take the line labeled else and follow it to execute the alternate block of statements. So this block of statements is equivalent to this block of statements over here. After the else portion executes, we will leave the if-else statement and we're done with the if-else, and that's what this arrow is showing you there. That's the flow chart. Let's wrap it up and move on.